So number one, so given just a equation like so, make it simple. First thing they're going to ask for is to find dy dt given x equal to 4 and dx dt equal to 2. And then part B, find dx dt given that x is equal to 3 and dy dt is 5. So first what you got to do first is take the derivative of both sides with respect to time. See how they all have dt's everywhere. Isolate the dy and dt and then plug all this in. So first step, is step one. Take the derivative with respect to time, d dt. So d dt of 2x squared plus d dt of y squared equals d dt of 40. All right. So what is this derivative going to be here?
2x.
That's pretty close. It's going to be, the 2 is going to come down, right? But what about the implicit part? Because it's not no longer matches, right? So last time we said you would take the implicit part and add the dx dt. So since it's no longer with respect to x on an x, treat it like you would the y prime or dy dt. And this would be treated the same, except it'll be with dt. See what I mean? dy dt. Does that make sense?
Yeah.
So we're taking the derivative of everything with respect to a variable that's not part of the equation, right? We're taking it in terms of time. Okay, excuse me. So once you do that, isolate for the part that they want. So part A, just isolate dy dt and plug in these two. So and move this guy over here, divide by 2y, and then plug in this nonsense. Although we don't have y, do we? So how would you find y?
in for x, right?
Yeah, we have X, right? So just plug it in into here. So plug in X and find Y. So 2 times 4. I'll put 2 pluses there. That's weird. Plus Y squared equals to 40. So it'd be 2 times 16 plus Y squared equal to 40. That's gonna be what? 32.
We're unable to see the screen. Yeah.
Thank you. Subtract the 32. Running out of space. Let's skip some minor steps. Y will be plus or minus square root of 8, which is plus or minus 2 root 2. Okay. You guys cool with the algebra that I skipped here, solving for Y?
Yeah.
Let me know if you have a question here. If not, I'll move on the next page. Okay. All right. Where were we? So we found Y. So back to dy dt, right? Yeah, it's 2Y. Okay. So this point is plug in your 4 for X, your 2 for dx dt, your Y for 2 root 2, and dy dt we're going to solve for. All right. Since they're all numbers, it's not as bad. Just move this guy over here and then divide by this. So this will be what, 32 plus 4 root 2. So dy dt is negative 32. Divide this garbage. It'll be negative 32 over 4 root 2, which will be negative 8 over root 2, which I think is good enough, but they might make you rationalize. So if that happens, multiply by root 2, that'll get us in negative 8 root 2, which will finally get us to our answer. 4 root 2. But you see all we're doing, right? We're just plugging in unknowns and knowns and solving. Nothing crazy. The only new stuff is do the implicit derivative, plug things in. Any questions about the algebra or the concepts or the calculus step? All right. So the first few questions will be like this. Go ahead and do part. Then we need to do part B. It's the same thing. Let's move on to number 2. It'll be similar, just a little harder.
Could you go back? I was still writing down something.
Oh, yeah, of course. I'm sorry.
It's okay.
No rush. Technically, we have all night.
Okay, got it.
All right, one moment. Okay, so number 2 would be exactly the same. It's just the derivative part will be a little harder. So the difficulty just changes depending on the equation, right? I'm sure you've noticed that. So same nonsense. So part A, find dy dt given x equal to 8 dx dt equals 13. What is y? If x is 8, y is pretty obvious, right? Yeah, see it? Yeah, it's gotta be, right? But technically, we have y. Let's skip this step, right? But actually, that looks weird. Okay. I'll make the note just in case. I think this is good to solve for y at the beginning. Last time it was a little weird to do it in the middle. So just plug in the 8, divide both sides by 8. There we go. All right, cool. Now, I'm gonna do the same thing we did before. Step 1, take the derivative with respect to time on both sides. This will be a product rule. The derivative of x times y plus the derivative of y times x. So derivative of x will be 1 dx dt times the y plus derivative of y will be 1 times dy dt times your x equal to 0. All right, you guys cool on the product rule? All right. Excuse me. Okay, so this is plug in everything and solve for dy dt. So dx dt is 13, y is 1, dy dt is what we're looking for, x is 8. So let's skip a minor algebra step. You get negative 13 over 8. Is that okay?
Just one minor question that I'm a little confused on.
Sure.
So when we put d dt for xy, and we get the derivative for that, which is the 1 dx dt, the x goes to y. The x changes to a y, right?
Yeah, so derivative of x, right there, will be 1, like you said, times dx dt. So that's the first derivative. This is the product rule for the first part. This is like f prime g plus g prime f. Does that make sense? This is like my f and my g, I guess. I don't know if that helps or is if that's more weird, but
That actually helps. Thanks.
all right, cool. So at that point, just plug stuff in and isolate this piece. Any other questions? Cool. All right. Anyway, we saw for what they wanted, given the inputs. So is a general big picture make sense? We're going to do some actual applications at this point. All right, so we did all this just to practice the notation, plugging stuff in because we're going to do word problems. And we're going to be solving for specific things like the rate of the area increasing over time, rate of the radius, or whatever the hell they're talking about. Number 5. So the radius r of the circle is increasing at a rate of 5 centimeters per minute. Allergies are getting me. Find the rate of change of the area when r is equal to 38 centimeters. Okay. So that's all the information you're going to get from the problem. So you need to know, what is the area of a circle? Like from elementary school. Remember? What is the area of a circle?
Is it pi r squared?
Yeah, so we're going to use this guy for our, because they want to know what? Find the rate of change of the area. So we're going to need an area formula, and we have to take the derivative of area over time. So we need this to start with. Now, what else did they give us here? Let's write down all the information. So the radius was what? Did they tell? Yeah, it did. The radius is 38 centimeters. This is a 5, by the way. So what is this right here? This 5 centimeters per minute. Okay. It says the radius of the circle increasing, right? So remember that all derivatives, derivative r, it says per minute. So that means it's the change in r, dr, over the change in time, dt, right, is equal to 5 centimeters. Do you guys remember what the per means, right? When they say 5 miles per hour or centimeters per minute, like, what does that mean? It's a ratio, right? Yeah, it is technically 60 minutes or 60 seconds, right? So for every 5 centimeters, you go one, it happens in 1 minute, 5 centimeters per minute. So per is actually just a division or a ratio, fraction. Okay, so all this is given to us. This we have to write down ourselves and remember what a radius area of a circle is. Now we can begin. Any questions on the setup? Okay, so here we go. Derivative of both sides with respect to time. This will be 1 times dA dt. This will be 2r times pi times dr dt. You guys cool with the derivative step?
Yes. All right. So they want to know what is the rate. So remember, dA dt is the rate of change of the area over time.
what is the rate of change of area when the radius is 38 centimeters? Well, plug this in, and it will know. So dA dt is equal to 2 pi times r 38 centimeters times dr dt, which is 5 centimeters per minute. I don't know what that is. 2 times 38, 380, right? Yeah. This would be 380 pi. Centimeters times centimeters is centimeters squared per minute. Do these units make sense? When you're talking about area, it better be a squared unit, right? Like square feet in your apartment or whatever. It needs to be squared. So it makes sense that centimeter times centimeter appeared. Because this is the rate of the changing area every minute. This is approximately something. Yeah. Multiply the pi if you want. Okay. You guys cool on number 5? Nice, that's good. All right. Let's do one more. Then we'll move on. The radius of a sphere is increasing at a rate of 6 inches per minute. Excuse me. Part A, find the rate of change of the volume when R is equal to 10 inches. B, find the rate of change of the volume when R is 36 inches. All right. You guys remember the formula for volume of a sphere? Yeah, that's the one. 4/3, yeah. We're gonna need that guy. What else? What else are? Or what have you been given? Yeah, for sure. We got two different radiuses for two scenarios. What is this guy? What is this? Yeah, DRDT. So DRDT will be the same for both problems. Be 6 inches per minute. Okay. So part A. Well, actually, before we start A, we should find the derivative. Okay, so this will be 1 times dv dt equal to 4/3 times 3 pi times r squared. dr dt. Sorry. So we have dv dt equal to 4 pi r squared. dr dt. I'm out of space. I'm gonna do it over here. Part A, dv dt will equal 4 pi times 10 inches squared times 6 inches per minute. So that'll be 2,400 pi inches cubed per minute. Now, if we change the radius, we will get 4 pi times 36 squared times 6 inches per minute. That'll be some huge number. Yeah. Okay. Does it make sense that we have inches cubed for volume? All right. You guys cool on number 6?
For the test, will it be okay if we use the pi, or do you want us to calculate that?
I mean, either one's fine. You can leave the pi or you can plug it in.
Thank you.
For 3.6 and onward, like 3.7 and 3.8, I can't seem to access them.
When
Like-
was the last time you checked?
I tried before I tried joining. Yeah, it says it's acting like I submitted it.
Hit refresh and check one more time. If you don't mind.
Yeah, it says submission details 0%.
One moment. Yeah, it says it's open. It may have. Can you open it and go to the problems?
Okay, I refreshed. Okay, I go to 3.6 related rates, and no, there's no link available. It's acting like it's been submitted already.
Let me see. You mind sharing your screen?
Sure. Here, give me a sec.
Let me turn that on for you too. There we go. Okay, so here's some formulas for the derivative of sine inverse. Basically, you're going to get the derivative of the argument, whatever that is, over square root of 1 minus the argument squared. For you guys cool with the -1, or do you prefer arc cosine?
-1 is good for me.
Cosine inverse will be the same, or sine, cosine. They're just a negative built in. So the derivative of the argument over the square root of 1 minus x squared. Tangent inverse derivative will be x derivative over 1 plus x squared. All right, so that's mainly all we need. So just follow these formulas, and you'll be good. Let me show you number 1. Find the derivative of, in the book, I think they use arc cosines. Let's go ahead and use both of them so we're comfortable. Arc sine of x minus 4. Same as sine inverse of x minus 4. Just in case you forget. So the derivative of f will be derivative of this guy, whatever that is, over the square root of 1 minus x minus 4 squared. All right, so what is the derivative of the top part? Remember, it's all respect to x, no time or whatever.
Is it 1?
Yeah, it'll simply be 1, right? And then just do this algebra and you're done. 1 minus square that garbage, x squared minus 8x plus 16. Okay, at this point, the calculus is done. But we can combine this, that'll be what is that? Negative x squared plus 8x negative 16 plus 1 negative 15. Any questions on applying the formula? Okay, so no, let's do another one. Number 3. And the derivative of g of x equal to 4 arc cosine of x over 2, which is the same as 4 cosine inverse of x over 2. All right. So d dt of g would be equal to, right? We said the force is going to come for the ride. Derivative of this thing over built-in negative for cosine square root of 1 minus x over 2 squared. Which will be oops. Derivative of x over 2, what is that going to be? The derivative of this is just a half, isn't it? At this point, the algebra is done, and or I'm sorry, the derivative is done. So just simplify this and you're good. I think -2 over square root 1 minus x squared over 4. It's good enough. You can combine these if you want, but yeah, I don't know if I care enough. But well, I guess it would reduce. Combine these two fractions. You would get 4 minus x squared over 4. You can square root the 4. So it'll come out as a half. Which will flip over and multiply on top. This would be the pretty version. Any questions on number 3? Okay. All right, last question. Number 4. Find the derivative of y of x equal to e to the 5x sine inverse of just x, I guess. Oops. Blurry. Okay. So the derivative will be the derivative of the first part times the second part plus the derivative of the second part times the first part. So the derivative of e to the 5x will be itself times 5. Here's the chain rule. Plus derivative of this, we said, would be 1 over square root 1 minus x squared times e to the 5x. So derivative of the second times the first. This will become 5 sine, I'm sorry, e5x sine inverse plus e5x square root 1 minus x squared. That's pretty much it. I mean, you could factor E5x. And that's about it. But yeah, the whole section is just use the formulas and you'll be good. Just don't forget your product rules or chain rules or, whatever. Any questions on this section? All right, guys, let me take roll and we can stop here.